like medical visualization and would like to know how we improve the exploration of radiomic tumor profiling data, stay tuned for RadEx. So here you can actually see an image of our application called RadEx. Now let's start right into the introduction. So here you can see the Norwegian cancer report from 2018. You see the red line rises up slowly, which is the incidence rate of gynecological cancer, and the highest line in the figure is actually the survival. So which is quite good, is that the survival rate is going up, but also the incidence is. And here we are starting into. We are primarily working with endometrial cancer data, which is the most common gynecological malignancy in female. And what we are trying to do is to support the clinical personnel in analyzing the data to in the end figure out a personalized treatment for every patient they have. So what you can see here is multimodal images of the same region within the body. So here it's, for example, the tumor which is within the endometrium. This tumor you can analyze in different modalities which you can derive from MR imaging. And then secondly, with our contribution now, we're taking into account radiomic tumor profiling data, and also for that problem, our collaborators in Norway have some related work where they analyze if these features that are derived from radiomic tumor profiling are linked to some clinical parameters, for example, aggressiveness of the tumor. We already have a previous project in that field called Paraglider, and I will put a QR code here, and when you scan that you can actually see my presentation about our paper. And what we did there is to focus on a single patient, and what we're doing right now in this contribution in RadEx, we're focusing on cohort. So as in comparison, you can just see me here standing in the middle of nowhere, and only when we zoom out you can actually get a bigger picture. So you see that I'm standing in the middle of a village here, and then you can see that there is a lake quite close, and the further we're zooming out you can see more and more details. For example, there are some cows here at the bottom of the screen, and this is the same what we do from Paraglider to RadEx. We focus out from one patient to a cohort, and that allows us to gather more information which we can then afterwards relate back to each single patient of the cohort. So now to the medical background. So what are we doing with radiomic tumor profiling? Radiomic tumor profiling starts out with for example, MR imaging. So in this case here you can see an MR imaging of the endometrium. Within this endometrium there's endometrial cancer, which you can see here while I'm moving the mouse within. And now what we're doing is we're segmenting that cancer, and it could be a manual segmentation, but that can also be a machine learning based segmentation, and you can see it here. In that case, for example, you can also see metastases highlighted. And when we go from there, we can say we have multiple MR images from the same tumor volume. We have the tumor segmented, and what we can do now is we can extract features out of the tumor. So we have shape features, and from there we can go to statistical features telling us, for example, the variation in data throughout modalities where we have the data from. Or we could also go in the direction of textural features, which could, for example, tell you something about the inhomogeneity of the values within the tumor in all different modalities. And with all these features we can then go into a feature selection process. And these features are selected based on their correlation with clinical parameters. So that's then the analysis step. In the analysis step, we figure out how these radiomic tumor profiling features are linked with clinical parameters. And that step is not easy to do. It also depends on how much data you have, and it also depends on what questions you ask, for example. So here you could, for example, say, are there any radiomic tumor features which are linked, for example, to the aggressiveness of the tumor? Now, in that field, there's a whole body of related work, and you can check it out in our paper. And how do we differ from these papers? So in comparison to all the related works we state in our paper RadEx, we work with multiparametric imaging data, combine it with radiomic tumor profiling data, and we also take clinical parameters into account and put that all into one application called RadEx. So here about the data and the tasks. So the data, we are quite fortunate as we are working closely together with our clinical collaborators. We have a lot of imaging data of many patients. So you see here we can actually use 7 different modalities for every patient, and these are for example called ADC, AUC, B1000, T2, time to peak, peak enhancement, and VIBE. And all these modalities are derived from the MR imaging that is conducted for every patient. And these imaging modalities are standard modalities that are acquired for every patient that has endometrial cancer. And you see now these 7 different images, and in every image the tumor is segmented and they're nicely co-registered. But this is not always the case, which we will see later. Further to the imaging data, we have the clinical parameters. So these 2 are delivered to us by our collaborators. And in the clinical parameters, you could, for example, see how long did this patient live. For example, there are also parameters which are derived from a biopsy. So you could see, for example, the phenotype of the tumor. And then also there's some staging parameters telling you how aggressive the tumor is. And in the end, you also have the outcome. So it's like how long did the patient, for example, live after surgery. And in the end, what we also derive from this imaging data is the radiomic features. And these 3 are then combined in the end to formulate hypotheses, or also to see if hypotheses that have already been shown in the designs of our collaborators hold up to this cohort. So now, what are our tasks now for RadEx? So we have our tasks are separated in 2 phases. So phase 1 is the data quality check. So in the beginning, we need a pre-processing step. We get all this data from our collaborators, we have the segmentation and everything. What we are doing in the beginning is just making it ready to load it in our application. So we have some pre-processing steps to generate the slices, for example, to generate icons, and to make it very easy to work in the end of the application without having to wait for the application to react. Secondly, we have to discover invalid co-registrations. So what happens there is like we have 7 modalities, and during the time the patient lies in the MR machine, the bladder of the patient could fill up. And that leads to a shift in the structures you have in the imaging volume. And for these things you need to do co-registration. That means every image you get from the MR, you need to register to each other. And in that process also problems can occur. And these we need to filter out, and then we can think of how we could correct them in another step. And this correction is not part of our application. Secondly, we need to discover incorrect machine learning tumor segmentations. Machine learning segmentation of tumor volume is a quite new field, and we actually have a collaborator at the MMIV, our institute, who published on that topic, but machine learning segmentations are not the ground truth yet. So there are some errors, and these we need to find out and filter out, because when we take incorrect machine learning based segmentations into the cohort analysis, in the end our results will most probably be wrong. So that's also one step within this data quality task where we need to find out these, and for now we just filter out them, but we could also feed them back to the machine learning algorithms in the end and make it better. And now we are in phase 2, which we call search and query. So what we're doing here is one big task is group selection and comparison. So our whole application builds up on group selection and comparison. And what do we want to compare? So we have 2 further tasks we can do here. One is homogeneity analysis, and one is the analysis of the radiomic features. Why do we have this inhomogeneity or homogeneity analysis there? Our collaborators already published some hypotheses that this can be linked to tumor aggressiveness. But the problem is you don't only have one way to calculate inhomogeneity within the tumor, there are several ones. And this could be a hypothesis or an exploration task where you say, I'm loading a certain amount of patients and I would like to see which homogeneity measurement splits the patient group into 2, for example, aggressive and non-aggressive, or like died from disease and didn't die from disease. That could be one task. And that you can do by iteratively select groups and then compare them to each other based on the parameters. And the second one is the analysis of radiomic features. You can broaden it up. You don't only have to look at homogeneity, you could also look at several radiomic features and see how they split our patients into different groups based on clinical parameters. So let's have a look at RadEx.
We have developed an application called RadEx, which uses a variety of multiple linked views, interactive group selection methods, and custom feature selections to fulfill these requirements.
It consists of a central scatterplot view, a parallel coordinate plot, and a unit chart, as well as a settings section. Every circle in the scatterplot represents one patient and contains a tumor icon, which can be further explored by zoom and pan interactions. Tooltip reveals an interactive image slice view with overlaid tumor segmentation. Extended tooltip shows all imaging sequences. Group selections are possible in all views. Selections can be expanded with an AND operator. A group of patients defined by multiple clinical parameters can be combined using the OR operator. Dimensionality reduction. The 1D dimensionality reduction is fully customizable and is currently taking size and ADC values into account. Grouping along the y-axis share characteristics revealed by group selection. Patients in the two groups share similar size characteristics, but they differ in the ADC values. Now on to the homogeneity analysis. Homogeneity is a tumor texture feature, which can be measured in many ways and for all possible sequences. The current homogeneity measurement seems to split the cohort by tumor aggressiveness, which can be seen by different clinical parameters like the status and the existence of metastasis nodes. When we select only patients with metastasis nodes, we can see that they're all aligned on a range of higher X values. Imaging modalities can be deselected to analyze the influence on group separation. Different homogeneity measures can be explored. So this was RadEx, and now I would like to show you two individual case studies which you can analyze within RadEx. So the first is the segmentation validation. So what you can see here is with this interactive group selection and group comparison task, you can find invalid segmentation. So for example, one thing you could do is you can just select outliers and the different imaging modalities, and then you could check, are there on one side, it could be that that's a group of patients which has completely different values in one modality, and that could also be, for example, linked to some outcome variables. But on the other side, this information can also be used to just see, because if my segmentation is completely off, maybe it's not in the endometrial cancer, it's in the bladder or somewhere, then these values will also be off because you're not segmenting the structure of interest, what you can see here. And the second task is the co-registration validation, where you can also do a similar process. You can again figure out outliers, because when I segment it correctly on the segmentation base, which is in our case the Weber imaging, you can then see, for example, if it's not correctly co-registered, the segmentation in another modality would segment something completely off, and there you would, for example, then also maybe segment the bladder or just some regions outside of the tumor, and this you would see in the average of the value. So to show the utility of our approach, we conducted an evaluation, and in this evaluation we included 6 different experts in the field. We invited the experts to work with our tool to have a look at different hypotheses they maybe already have about their data, and they could just also formulate new ones on the fly. And in the end, to get structured feedback from them, we have an evaluation form with 34 statements in 6 categories, and in the end we also conducted a system usability scale for our tool. For the system usability scale, we got an A+ or best imaginable, and now I show you the result of our evaluation in this table, and there's a color scheme which goes from red to green, and you can see here the most of the fields are greens, and most categories, or like in almost all categories, the experts were really happy with the results and they would actually like to use it for their clinical research. Now to the conclusion and future work. With RadEx, we are showing an interactive platform for radiomic tumor profiling data. We show that we have several use cases where RadEx is usable. For one side we have the segmentation validation, but we also have the exploration of tumor characteristics. We have some findings So we can show that well-established associations between the inhomogeneity and the aggressiveness of the tumor hold up. And on the other side, we can also find potentially interesting new associations within RadEx. And now to the evaluation, we got very good feedback both in the quantitative and also in the system usability scale. And for the future work, we would like to widen the scope of RadEx, so it could be on the one side also opened up for other gynecological malignancies, for example cervical cancer, but we could also broaden it up to other types of tumors, for example for prostate cancer. So thank you very much for listening to my talk about RadEx. And now I would like to invite you for a quick flight through the amazing scenery of Norway.